This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session that is Big Data Masters program. So, friends, in previous session, what we have seen the the Linux and Hadoop command, and we have gone through in detail with respect to the Linux and Hadoop command, and we have seen like how to create a particular file, then copy, move, remove. Okay, these particular things we have seen with respect to Linux and Hadoop as well. And why we need to have that? Because like we have started our journey in a new domain, and this is the basic foundation. And if the foundation is strong, then we will be able to deliver more. So today's agenda, it will be the MapReduce. So we are going to discuss about MapReduce in our today's session and what exactly MapReduce is. So probably you all are able to recall that Hadoop is having three main components. Okay, Hadoop HDFS, that is Hadoop Distributed File System. Second one is MapReduce. Okay, that is the combination of two things, mapper and reducer. And third one is yarn, that is yet another resource navigator. So we were having two problems with big data. We were not able to store and we were not able to process. If we talk about the white papers which was published by Google in 2003, so HDFS was the solution in order to store huge amount of data. And so far we have discussed about HDFS only. Say how to move a particular file into HDFS, how to like create directory inside the HDFS, and how to get the data from HDFS. So these particular things we have seen in our previous session, and that is describing about HDFS only. Then what about this MapReduce? As we have started our topic with MapReduce, so what is the meaning or what MapReduce exactly is doing? Okay, so MapReduce is the processing framework in Hadoop ecosystem, or it is the component which is required for processing perspective, and that is the solution with respect to the Google white paper which they have published in 2004. So 2000 in 2004, Google published like how to process huge amount of the data, and they have given this particular solution, MapReduce. Okay, mapper and reducer. This is the combination of two things, two words, mapper and reducer. So mapper, like we are going to divide the task among different users or among different machines. If we talk about Hadoop, so the task has been divided into different machines, and then the mapper is going to provide us the intermediate outcome. Once we are having the intermediate outcome, that is given to the reducer, and reducer is going to work on to the output of mappers, and we will be able to get the final outcome. This is the functionality, and I have described it in our previous session as well. Then why we need to have this yarn? Yarn is yet another resource navigator. This is the resource manager. Over here we are having multiple resources, we are running with multiple machines. So how effectively we are going to utilize those particular machine, that is the duty of this particular component. So in short, what I want to say, Hadoop is having three components: HDFS, which is dealing with respect to storing the huge amount of data in a distributed way; then MapReduce, which is utilized in order to process huge amount of the data with the help of different machines available in the cluster. This is the processing framework. Then third one, Yarn, it is going to manage all the resources of Hadoop cluster. So These are the three basic components inside the Hadoop ecosystem. Let me open a notepad and start the day. So this is week 2 and day 4. And we are going to discuss about MapReduce. Okay. So MapReduce is the component that we are going to focus. So what I told, MapReduce is the combination of two words, map and reduce. MapReduce is the combination of two words, number one map, number two reduce. Okay, so mapper, let me mention mapper. It is used to distribute tasks, distribute tasks, tasks among different machines and process it and share intermediate outcome. So that is the functionality of mapper. Then reducer, what reducer will do, reducer it is it is going to take input from mapper and provide final output. That is fine now. Like this is the intermediate step, and this is the final step that we are having inside the Hadoop ecosystem, and we will be able to get final outcome from the reducer. The main thing that you need to note, this map and reduce both are working onto the key and value pair. Okay. The input to the mapper will be key and value pair, key and value. Okay. And output to the mapper, it will be key and value. Okay. So this will be input and this will be output. It is giving me the outcome in the key and value format. That is perfectly fine. Say, I'm going to take certain examples in order to give you the understanding, but at this particular point of time, you can think in this way. It is going to take input in key and value pair and provide the outcome in key and value pair. In the same fashion, the reducer is going to take input in key and value pair and provide the outcome in key and value pair. So let me mention, this is input and this is output. And we can mention it in this way as well. Okay, key and value, and I can say intermediate output and then final output. Final output. Okay, so I'm going to give the data in key and value pair. Then mapper will work onto that data. It will provide intermediate output and provide the result in key and value pair. Then reducer will take it. It will work on this particular data and then provide the output in key and value pair. Okay. That is perfectly fine. Now, what is the functionality? Yeah, functionality of MapReduce. So, suppose we are having a particular file. We are having a particular file, and that is of say 550 MB. Yeah, I'm having a particular file that is of the size of this particular file is 550 MB. Then it is given to a particular component called input split. Okay, so input split, because we know it very well, Hadoop is not dealing with the entire file. It is going to convert it in blocks, and then onto the blocks, the functioning will be done. So input split, what it will do, it will convert the file into blocks. Let me mention it over here. So input split, what it will do, convert file into blocks. Into blocks. Okay, so probably we will be having three blocks over here. That is perfectly fine now. Now, say block one, block two, block three. That is fine. But over here, say we are having mapper, then reducer, and then we are able to get say final output. Okay, but we are having a challenge over here. The block uh, which was generated with the help of input split, these are not having data into key and value pair, and we know it very well. The mapper is able to work onto the key and value pair only, so it is given to another component called record reader. So what it will do, say, let me take an example. Say I'm having data, hello, how are you. I'm having the content of this particular file. So this is the 550 MB file, and the content for this particular file, hello, how are you, well, welcome to big data world. Big data is going to replace the way of thinking. Way of thinking. So these are the, you can say, this is the data in this particular file, that size of 550 MB. Now it is given to input split, and what it has done, it has splitted this particular content into say three blocks. So once this is passed to input split, so let me mention, try to mention in. Okay, so it is given to say input split, and what it has done, say this is say block one, this is say block two, block two, and in the same fashion block three. So what it has done, the content say hello, how are you. This is given to block one. The welcome to big data world, it is given to block two, and big data is going to replace the way of thinking, it has been given to block three. Now we are having three blocks, but the challenge is we are not having this particular content in key and value pair format. So what will happen over here, we have added, the Hadoop had added another component called record reader. So these particular blocks will be passed from the record reader, and record reader is nothing but it is a random number generator. It is going to place a random number on each and every block. So say this is the content of block 1, and it is going to put certain random number onto this particular block. Say random number, say 2 1 3 4 5, whatever. Okay, this is the content of block 1, and say 4, and the content of block 2, and in the same fashion the content of block 3 with random number. Okay, this is not the case, like this is not the correct number. These are the random numbers generated by Hadoop by itself. So no need to bother like how this number is coming and what is the meaning of this particular number. There is no meaning. These are the random numbers only. Now, just try to look onto this particular data. Earlier, we were having this data in terms of blocks. Say block 1 is having this content, block 2 is having this content, and block 3 is having this content. And why? Because we have split it the 550 MB of file, and we got the data in terms of blocks. Now, the record number has been added once we pass these particular blocks from the record reader, and just have a look onto this. This is in key and value pair format. It can be act as a key, and it will act as a value. This is a key, this is the value, this is the key, this is the value, and that was a requirement. Mapper is able to work onto the key and value pair only, and because of that we need to have a record reader. If you are referring certain diagrams onto the internet, so reader will not be available, but we need to have record reader into the MapReduce functionality. So record reader is there and it has done its job. That is perfectly fine. Now it will be given to the mapper. Mapper is a rich guy. Okay, mapper is a rich guy. Basically, I used to say this is the rich person. Over here, we are having the benefit of parallelism. What does it mean? It means that multiple machines will work over here. Say, this will look like, say, mapper 1, mapper 2, mapper 3, mapper 4, based upon the cluster configuration. So, say, we were using 4 node cluster, and let me take one more block, 6, and I can say big data is the future. So I'm having 4 blocks, and let me mention block 4 as well over here, and block 4, and let me capture it over here as well. So we were having 4 node cluster, and the splitting has been done. 4 node cluster, and each and every block is given to one mapper. One mapper, you can say one machine. Say machine will work onto this particular block, machine 2 will work onto this particular block, machine 3 will work onto this particular block, and machine 4 will work onto this particular block. Whatever the function, whatever the logic I'm going to give, so this particular machine will work on our logic. And why I used to say like this is the rich person, because over here we are having benefit of parallelism. Whatever the data that we are supplying to Hadoop cluster, it will be mapped among the mappers of different machines, and those machines will work onto the data that we have fed, and we will be able to get the output. So that is perfectly fine. Mappers are having benefit of parallelism. Let me take an example of word count program. Word count program or frequency, word frequency calculator. You can, in some logical words, word frequency calculator. What this particular word frequency calculator is going to perform, say if hello is there two times, so it is going to list say hello comma 2. Big is say given four times, so it is going to list big 4, big 2 or big 4, based upon the count that we are having. If data is there three times, then it is going to list data 3. Okay, so it is going to count the frequency of each and every word which is given into this particular file. And the flow is very simple. The file will be split into blocks. Then record reader will come into the picture. Record reader will add certain random numbers. Then those blocks will be given to the mappers, because now we are having the data in key and value pair. Once we are having the data at the mapper side, then it will work onto that particular data, and it will work based upon our logic. So we need to write down the logic for mappers. Up to so far, like the Hadoop is doing its job. But what do we want from the Hadoop? So that is the, we need to have logic for that. Say if you want to calculate the frequency of word, then you need to provide the logic to Hadoop. Like map will work in this particular way. If you want to find out the sum of certain numbers, then you need to write down the logic for identifying the sum of those numbers. If you want to create or develop a calculator, then you need to write down the logic. Okay, another important stuff, guys, these particular things will be written in Java. And you might be thinking that do we need to learn Java? So friends, for this particular course module, there is no need to learn Java. But in order to understand the functionality of different components inside the Hadoop, we will be going through with simple programs, and I will walk you through with the logic. There is no need to go through with the syntax and all, how to import libraries and all. So there is no need to bother about that particular stuff. What you need to focus, you need to focus on the logic. Like say if I'm going to write down a program for frequency calculator, then how things will happen in MapReduce perspective. Okay, so up to so far, so file is there, and reader has converted it into key and value pair. It has been given to the mapper. Now, what I can do, if I'm going to split these particular words and assign one with each and every word, then I will be having the outcome, and that can I feed to the reducer, and reducer do the calculation. So say for this particular block that is given to mapper 1, so this is the stuff that has been given to mapper 1. Mapper 1. Mapper 1 is having this. Mapper 1. This is the input to mapper 1, and what will be the output? Let's mention input to mapper 1. input to input, and what will be the output, huh? So output, for output I need to write down the logic. So what I can do, output, huh? So what I can do over here, I can discard this particular random number in order to, you can say, have the input in key and value pair. I was in need of this particular random number, but once it is coming to me, I can discard it and I can write down the logic. So it will discard this particular random number and it will split it based upon say space, okay, and assign one to each and every number. Say if we are feeding this to mapper, and what will be the outcome from mapper, say hello comma 1, this is the first number, and how comma 1 r comma 1, it has been splitted, and now we are having unique words, r comma 1 and u comma 1, okay. And over here, if you are able to see, this is the key, this is the value, this is the key, this is the value. And the clause that I have written over here, that MapReduce is able to give the input, take the input in key and value pair, and it is providing the output in key and value pair. That is also meeting up. So mapper1 has given me the output in this particular format. Say hello 1, how 1, r1, and u1. And why I need to have the outcome in this particular way? Because somehow like my logic will move in this particular way. So the motto was, if I'm having each and every word, and if I'm having the count or number for each and every word, say hello is, hello one is there, how one is there, and I will be able to get the outcome with respect to each and every block. Say mapper 2 will provide its output, mapper 3 will provide its output, mapper 4 will provide its output, then what will happen, I will arrange these particular keys. Say hello is there in say block 1 and block 2, so hello 1 from block 1 and hello 2 from block 2. So what I will do, at the reducer side I will keep the key and do the sum onto the values 1 plus 1, okay, and I will be able to get the output, say hello 2, that is hello 2, and that is nothing but the AND output, I want to have output in this particular way, so I proceed to give one, to map one with each and every value that is given inside the mapper, so I have splitted this particular content based upon the splitter that I can have. Say if you are having a splitter space, then you can split it with space. If you are having a splitter semicolon, then you can split with semicolon, pipe symbol, based upon the data that you are having. Over here we are having say space, and we can split it with the space, so we will be having these words, and I will map one with each and every word, so I will be having the output from the mapper that will look like this. So mapper will, one has given me this particular output. In the same fashion, what will be the output from the mapper 2, okay, so it will be look like this. Input I need to map on. So this is the input to mapper 2, and mapper 2, this is the input to mapper 2, And what will be the output from mapper 2? Friends, tell me, what will be the output from mapper 2? Guys, please be interactive. Akhil, Kishan, Ram, Naresh, Rohit,
Sir,
please be interactive.
2, comma 1,
2,1,
big comma 1, big comma 1,
big
data comma 1,
data comma 1,
and
and
world comma.
world comma 1, no? And that is based upon our logic, huh? My expectation that I'm going to split this particular content and map one. So that is perfectly fine. Huh? So this is nothing but intermediate output in this from the mapper one, the hello is one. And if say we are having two hellos, it doesn't mean like it will list hello two over here. No, it will list hello one and then hello one. That will be the another word. Huh? So up to so far that is perfectly fine. Our mapper has done its job. Now it came to the reducer. So mappers and reducers, these are nothing but machines. These are machines. And once I need to move the data from one machine to another machine, friends, that is the costly operation. Costly operation in terms of latency. And in the big data world, you need to focus to minimize this particular shuffling. Shuffling is a process. Let me mention shuffling. Shuffling. Shuffling will happen, and then records will move from one machine to another machine. That is perfectly fine. What will happen once I am going through with shuffling? Shuffling is going to map that the key that a key will be given to a unique reducer. It might be possible that multiple reducers are there. This is who is going to decide like how many reducer you want to have. Okay, you can decide the reducer number. So if hello is moving, let me try to map it in another words. Say diagram. Once we are having two reducer, and who is going to decide? We can decide like how many reducer we want to have for our functionality. And this is something like a little bit parallelism we are going to add at the reducer side. So say we are having two reducer, reducer, reducer 1 and reducer 2. Okay, now let me show you one diagram, then things will be you will be able to correlate, things will be more clear. And these are the things what we have discussed. Okay, what is the input split, what is the record reader, what is mapping, shuffling, sorting, partition. So we are going to discuss about these particular things, partitioning, shuffling. Just have a look. We are passing something that is, say we are having a data that is having certain animals name, dog, cat, mouse, dog, cat, dog. Okay, now splitter, what it has done, it has splitted this particular data, say three blocks. First block dog, cat, mouse, second block dog, cat, and third block dog, cat, dog. Now what the mapper has done, mapper has assigned one, mapper has splitted this particular blob. Further, it has been splitted. Then it has assigned one to each and every, you can say, word that is given by the splitter. Okay, that is perfectly fine. Now shuffling will happen. Shuffling, that is movement of records from one machine to another machine. Now over here, over here, say we are using for reducer. We are using for reducer. So shuffling, inside the shuffling, it has been decided that which key is moving to which reducer. Okay, which key is moving to which reducer. So say each and every mapper is going to place, say, the cat key to this particular, you can say, we call it partitioner. So we are going to call it partitioner. So it is given to this particular partitioner. Then dog is given to this particular partitioner. Duck is given to this particular partitioner, and mouse is given to this particular partitioner. So we are using 4 partitioner over here, and number of partitioner are equal to, partitions are not added. So that after shuffling and sorting, like shuffling movement of the records, and sorting, like we are alphabetically sorting this particular data. So shuffling and sorting will happen. Then it is given to partitioner, and partitioner is going to decide like which key is moving to which reducer. Number of partitioner will be equal to number of reducer. Let me open an Excel and try to give you the insight. So let me take this one, dog cat mouse, and then dog cat, and then cat dog. Okay. So that is a block. Block. Then this will be given to, say, record reader. We know it very well. I'm skipping that particular step. Then mapper will come, and what the mapper will do, it is going to, say, place one with each, you can say dog one, cat one, and mouse one. In the same fashion, say mapper one, mapper one, then mapper two over here, and it is dog cat. Dog, dog, and cat one. And then mapper three. So mapper three, what it will do? Dog, cat, dog. Okay, so that is fine. Let me increase the size a little bit. No. Okay, so mapper, this is nothing but the mapper phase. Now it will be given to shuffling. So shuffling, what it will do? It will sort this data. Okay, it will move this particular data from, say, mapper machine to reducer machine, and it will sort it, alphabetically sort it. So say cat1, 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 and then cd, dog1, dog1, one, dog1, and then duck1 and mouse1. Okay. So fine, that is perfectly fine. So shuffling and sorting has been happen. Now in this particular case, the example that I was showing, so we were having we at this moment we were using say four partitioner over here or four reducer, but uh, the number is not mentioned, but the number of you can say reducer. Okay, shuffling and sorting. This is the shuffling and sorting phase. Now try to think, we were having three mappers, that is perfectly fine, three mappers were there, and those mappers were having certain output, and that has been given to that has been shuffled and sorted, and now it is further given to the reducer to have the final output. Now these are the key and value pair, which key will move to which reducer, that is decided by another person, that is called partitioner. 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 So partitioner is going to decide which key is moving to which reducer. Now the number of partitioner will be equal to number of reducers. Say if you are using one reducer, so one partitioner will be there. One partitioner will be there. One partitioner, what it will do, it will take all the keys and it will forward these particular keys to the reducer. But once we are moving with one reducer, do we really need partitioner? Just try to think, partitioner is a person who is going to decide like which key is moving to which reducer. Now we are having say one reducer only, then do we really need partitioner? Try to think an answer, and it's replicated to all.
And I think there is no need of partitioner
I want input from each and everyone. Why?
because it's only the input we are taking his single input and same single output he is given to the reducer, and there is a single partitioner, single reducer. So I think there is no need. We can directly put to the reducer also.
That is fine, like if we are not doing anything
Yes, sir.
onto this particular phase, then why I need to have? Because we need to write down the logic for partitioner as well. Like say I want to move these keys to say this particular reducer and say these keys to the another reducer. Say I'm having two reducer, two reducer. Now you will be having the better understanding. Reducer one, reducer one. What is that one? reducer 1, and let me copy reducer 2 as well. Then partitioner 1 and partitioner 2, 1 and say partitioner 2. Okay, so over here, say what it will try to do, it will try to the partitioner will work based upon certain hash keys. Like if you are not defining, if you are not providing any logic, so it is going to work onto a particular hash function, and that is nothing but, say, let me mention partitioner is a person who is going to decide which key will move to which reducer. That is fine. Now, how it will work? How it will work? It will work. It will work based upon certain logic. Say hash key, hash function, certain inbuilt hash function, hash function. If you are not defining, if you are not defining any logic, then it will work on inbuilt hash function. And second, first say you can define your own logic. Okay. Second, if you are not defining the logic, then it will work onto the hash function. So, what is the meaning of hash function over here? So, say it is say it will be working like this. Hash function, that is nothing but the modulus division. Hash function is nothing but modulus division. Say I'm having three mapper. Mapper 1, mapper 2, mapper 3. Okay, so mapper 3 and mapper 3. So 1 divide by modulus division, say 2. 2 is the total number of reducer that you want to have. So I'm having 3, you can say, mappers, and I just want like of the key which of the key will move to which reducer. So I'm having two partitioner or two reducer. So if I'm having two reducer, then it will work like 1, that is nothing but the mapper number, and modulus division 2. So what will be the outcome, friends? Output, it will be, it will be 1 modulus division 2. It will be, the remainder will be,
0.5.
no. Modulus division, we are targeting the remainder. So it
Point
will
five
be 1.
remainder. Okay, okay.
Yeah.
Remainder will be
One.
1.
Yeah. So
Actually, we define the logic what we require. So that's why we putting the output.
no, this is the inbuilt logic. We are
Yes,
not
yes, yes.
defining. I'm just giving you the insight how the hash function will work. You can define your own logic. That is perfectly fine. But if you are not defining any logic, then the hash function will work. And what is the hash function? It is nothing but the modulus division. If you are having three mappers,
Okay.
so one modulus division 2, so remainder will be 1, so records will move to reducer 1. Okay, 2 modulus division 2, and remainder will be 0, so record will move to the reducer 0. If we are having 3 modulus division 2, the remainder will be 1, and the records will move to the reducer 1. So in this particular way, say the the records from the mapper 2 will be moved to reducer 1, will be moved to reducer 1. So this is a kind of hash function that is having, and it is also, you can say, taking care that a key will be given to a particular reducer only. Say if I'm having cat and it has been given to say reducer 1, it is not possible that cat will be moved to reducer 2 as well. It is the duty of this partitioner that unique key will be moved to a particular reducer. Like cat, if the cat is moving to reducer 1, so cat will not be available onto the reducer 2. If like say the cat has been moved to reducer 1 and 2, then the final outcome will not be correct, right? So it is the duty of partitioner that a key, unique key, will be moved to a particular reducer. Okay, like cat will be given to reducer 1 only, then all the data with respect to cat key will be given to reducer 1. Say if we were having 500 mappers and 500 mappers were having cat, so the data from all 500 mappers will be given to reducer 1 only. If the dog is given to reducer 2, so all the data from all the data with respect to dog from all the mappers will be given to reducer 2 only. Okay, and that you are able to see here. Say if cat is given to this particular reducer, all the cats are available over here. Then dogs are available over here. Duck is available over here. Mouse is available over here. Because we need to have the final outcome. Our logic, I want to write a logic onto the reducer side that I need to keep the key and perform the addition onto the values. So if cat is there, I will keep the cat and 111. So cat 3 will be there. Dog, so dog 1 1 plus 1 plus 1 plus 1. So 4 dogs are there. And duck 1, so duck is not the repeated value, so duck 1 will be there the final count, and mouse 1 in the same fashion will be having the one count only. So what we are able to see over here, so mapper we need to write down the logic, then for then shuffling and sorting will happen. Shuffling like movement of the record, sorting alphabetically sort that particular record. Then partition will come into the picture, and the partitioner what it will do, it will decide like which key is moving to which reducer, and it is working based upon certain, you can say, hash function, inbuilt hash function. If you are not defining your logic, then the keys will be moved to the reducer. Okay, now the reducer is there, and what we have seen, number of partitioner equal to number of reducer. Okay, that is the thumb rule. Now reducer, reducer, it is the poor person. poor person. Over here, we are not having the benefit of parallelism. Okay. Why so? What I have said, that if you are having mouse, all the mouse will be moved to reducer one. Say if I am if this particular, you can say, partitioner has decided that the records with respect to the mouse will be given to reducer one, then all the mouse will be moved to reducer one. If it has decided that cat will move to the reducer two, if the partitioner has decided that all the cats will be moved to reducer 2, so it will be moved to the reducer 2. Over here we were having cats, dogs, and you can say duck and mouse. These are distributed among different machines, but now it has been given to single machine only for the functionality or for having the final output. So that's why we call it like the poor person. We are not having the benefit of parallelism. Okay. And it is recommended that like, say if we are having the number of, you can say, reducers always will be less than to the mappers. The number of reducer will be less than to the mappers. That is the thumb rule, huh? If like we are having more reducer, then the functioning is not proper, the the cluster tuning is not proper, because reducer is something to reduce, it is not going to increase the output, huh? Or if you have defined more reducer, then like you are lagging in coding, huh? So that is the stuff that you need to think in your mind. Let me explain it once again. So blocks, like the data what we were having, it has been splitted with the help of input split. Let me walk you through with presentation. In presentation I'm having a good diagram. Okay. So what we were having a file that has been given to input split. Input split, it has splitted this particular file in terms of blocks. Okay, now these particular blocks are given to the record reader. Record reader, what it will do, it will going to add certain random numbers onto the data or onto the blocks. Now, why I need to pass it from the record reader? Because I need to have the input in key and value pair. Then it is given to the mapper, and mapper output will be in terms of key and value pair. Then partitioner, partitioner, this is nothing but, you can say, this is going to decide like which key is going to which reducer. For partitioner, we are going to write down the logic. So then sorting will happen, and the reducer phase came into the picture, and we will be able to get the final outcome in key and value pair. Say how the shuffling is happening, the movement of record. Say from this particular machine, say dogs are available onto, dog and cats are available onto this particular node. In the same fashion, dogs and cats are available onto this particular node. So dogs will be moved here and cats will be moved over here. It might be possible they are sharing the same reducer, or one reducer is there. So at that moment, like, those particular things will be given to one reducer only. Okay, and you will be able to get the final output. In that case, what I have mentioned, there is no need of, you can say, partitioner. Okay, so this is the flow, like how the MapReduce is functioning. One important concept that I am going to explain, that is over here, what I have mentioned, this reducer is the poor person. And like if someone is poor, then we need to offload that. Okay, we need to take the burden from that particular person. So over here, if reducer is the poor one, he is heavily loaded, then we, what we want, we are not having parallelism over here. So what we want to process the data where we are having parallelism. Okay, so we are having another person that is called mini mapper. Mini mapper. Mini mapper. So Minimapper is working onto the logic which is written inside the reducer. It is working onto the logic of reducer. So, and the main motto, like if you want to offload someone, then you need to take what he is doing. Okay, you take an example from your organization. If you want to offload a person, then you want to take the activities from that particular person and assign that activity to another person, like who is performing good or who is having certain less amount of, you can say, activities or responsibilities. So mini mapper is the person who is going to take the responsibilities from reducers. It is working onto the same logic which is written inside the reducer, and it is available inside the mapper machine called mini mapper. It is available onto the mapper machine because we are having parallelism over here. Multiple machines are working onto the data. So first level of, you can say, processing you can do over here, and you can think in this particular way. So mini mapper, what it will do, say, it has applied the logic which was written inside the reducer. So what it will do, it will try to do the sum over here only. So dog 2 will be moved in the same fashion, say. Okay, so we are not having say repeated one. Say this mouse one is also repeated. Say mouse two will be moved in that case. So try to think in this way. Previously, we were moving two records, and at this moment, we are moving single record only. Okay, key and value pair. So we were moving two records. Now we are moving one record only. So we have done the intermediate processing, or we can say temporary processing at the mapper side, and that is the same logic which is written inside the reducer. At this moment, what will happen? The data will be less inside the shuffling phase. And what I told, shuffling is the costly operation because the movement of data will happen over here. So we need to think in such a way that we can reduce the amount of shuffling, and it will definitely boost on our process. Okay, and we will be able to get the outcome with low latency, and this reducer will work less in that particular case. So mini mapper, mini mapper. Let me write it down. Mini mapper. It will work on the logic of reducer, which is and used to offload reducer. Okay, mini mapper. No? The component name is mini mapper. So what we are going to do, we are going to do these particular things practically, and we will be having different approaches. Practical. It will be like we will be having file. Then what we will do, will do splitting. So it will be passed through splitter, then record reader, then mapper and reducer. Okay, this is the first case that we will going to see. Yeah? Okay, for these particular things, these are taken care by Hadoop itself. So we are going to write the logic for mapper and reducer. Then second thing, okay, one important stuff that I want to ask. Okay, can we have certain operations where there is no need of reducer? Can we have certain operations where there is no need to have reducer? Can we have reducer less jobs? And is it preferred to have the reducer less jobs or not? Try to think and answer. Try to think for a minute and give me the answer. Try to think, guys. Can we have reducer less job?
Sir, when it were one or about one.
Hello?
I think with Minimapper we can do the
Sir,
same job.
sir, if we already use the mini mapper to reduce the function and same output is we given the reducer, then I think there we could remove the reducer and we use mini mapper at there by using do same facility by using the mini mapper.
Hmm. Okay, first tell me, like, can I have reducer less jobs? And if I'm having a job that is not having any reducer, that is a good job or not? If a job is not having reducer, then is that job good or not? Either that job is good or not. Okay,
But
let
it's
me
good.
explain.
Okay.
Okay, let me explain. So, what I told, like, mapper is the rich person. Over here, we are having benefit of parallelism. Now, after this particular phase, minimap, let me add minimap over here. After this phase, shuffling and sorting will happen. So shuffling is the costly operation. The data is moved from one machine to another machine, and then it is given to reducer. So if a particular job is not having reducer, that is the good job. Because why I need to
But in
have
that
shuffling
case,
and
sir,
sorting? Why I need to have shuffling and sorting?
yeah,
Because
to arrange.
no, 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 no. To move this particular data to reducer.
Shuffling is actually the it's collect the one type of data and give to the reducer.
Shuffling is what?
It's collecting one type of data and give to the particular reducer.
Mm-hmm. But if I take the output from here only, okay,
Hmm.
I do my functionality with Minimapper. Minimapper is doing what? It is going to
Reducer, reducer.
reducer function, na? And if I'm
Yes.
taking the output from here only, there is no need of shuffling and sorting.
Yes, sir. Yes, sir. Yeah, both process shuffling and sorting, and reducer can remove, sir.
Okay, perfect. Huh? So
But
for
there will be one issue, sir.
tell me.
I think if mapper one is giving the output mouse one, and the mini mapper will give the same job like reducer, mouse two will be shown, but still in the mapper one, dog one and cat one is also there, and mapper two is also having the dog one, so it will giving the direct two times dog one and dog one in the mapper two, and in mapper three again the dog one, and shuffling and sorting and reducing process will not be done on this case. But if we are going to the shuffling and sorting process, this will add the all the three mappers, dog one in one side, cat one in one side, and duck one in one side. After that, it will go to the partitioner, and the cat will go to the one reducer, and dog will go to the another reducer, and then duck one and mouse one.
That is also fine. That is correct. But in that case, friends, you need to think like where I can have reducer less job. That is not like replicated to all jobs, right?
Right.
Okay, so you need to decide that for this particular job, do I need to have reducer? Is there any way so that the reducer can be removed from this particular job, right?
Right.
So you need to think in that particular way that you can have reducer less job, right?
Sir, mini mapper is also working for dog one, cat one also, na? It's not only working for mouse one. It's also working for dog one, cat one also.
No, no, no. His point is like, say,
Yeah,
if
I
I
know.
need to,
Yes, sir, I got it.
if
His point also.
Mhm.
He's saying that the if it's categorize the data one, dog one, mouse two first time, and dog one, cat one, dog one second, and duck one are different. So all the three types of data is categorized, and then again shuffling and sorting and giving the partition of reducer. I know that, but it's same process we can add mini mapper add there, dog one, cat one there.
So let me give you one another example.
Okay.
Say we are having say Naresh and say Ram, Robin, Satish, Harry, okay, and Shivansh. Okay, these are the persons. Say name and say serial number. Let me add certain data. Serial number 1, 2, 3, 4, 5, 6, and then say category and say amount. And category say book, electronic, electronic, say clothes, in say book, book. Okay. So book and say then electronic and cloth. And say we are having certain amount, say 5,000, then 10,000, then 2,000, then 1,000, then 5,000, then 1,000. Okay, so we are having this particular data. Now, what I need to have, I just need to calculate which person has spent more than 3,000. So on mini mapper, on the mapper side only, I will apply the logic like person spend greater than say 3,000 Okay, so say this is given to say block 1, this is given to say block 2, or let me take say block 2, and this is given to block 3. Okay, block 3. So we are having 3 blocks, right? So what will be the outcome from block 1? So narration Ram, what will be the outcome from this mapper 2 or block 2? Satish only. And what will be the outcome from this block 3 or mapper 3? Harry and Shivanta. And is this the final outcome?
No. Shivans is having less than 3,000.
Okay, so
One is
let's
Harry.
go. Okay, I thought it is say 10,000. Huh? So perfect. Huh? So is this the final outcome? Huh? The main thing that you need to decide. Is this the final outcome? Say yes or
Percent
no. Is this the final outcome?
Yes,
Do I need to
yes, yes,
shuffle and
yes.
shuffle? Do
No,
I
no,
need
Yes,
no
sir.
to
need
Yes,
shuffle?
to suffer.
yes.
So that's what I want to say. You as a developer need to decide that my job can have reducer or not. Is there any way so that I can reduce or remove reducer? And that's what called optimization. Huh? It is not like say we blindly having reducer. Being a good developer or being a good architect, you just need to decide, can I
I
remove
mean, we
reducer?
have to decide according to the job.
Yes, you need to decide. And sometimes, like some jobs will come to you, some applications will come to you in future that you need to do the optimization. Then you need to search thoroughly. You need to look thoroughly that what is the function that is causing too much time. Over here, what what I have mentioned, shuffling is the costly operation. Data movement will happen over here. Okay, and reducer is not having parallelism. If I'm able to remove reducer, then definitely shuffling will be removed. Okay, so what I can say over here, if you want to do the optimization onto the reducer side, first one, like you can add minimapper, and second, like you can remove reducer as well. Okay, and that's what we are going to see. Say practically what we will see, the job which is having reducer 0. Okay, like reducer less job. Huh? First, like we are having map and reducer only, then we will set reducer to 0, or we call say reducer less job. Huh? Reducer less jobs. Then we will move further, and so by default, like it will have one reducer, and you can remove the reducer to 0, like you can have 0 reducer. So reducer less jobs. Huh? Is there any way that I can increase the reducer? Yes, you can increase. So third example, what it will be, like you can have two reducer. Then we know, like we can offload reducer with the help of what? With the help of minimapper. Minimapper or called combiner. Huh? Minimapper or combiner, both are the same thing. Huh? So we will see how to have combiners, and this is not the telecom industry combiner that is giving you 3 dB loss. Huh? Loss or gain?
Oh, sir.
Okay, so combiner is there. Huh? So we are going to
Combiner is giving loss or gain in telecom.
You need to decide, huh? You need to tell me. Just give me a minute, friends. Just give me a minute. Someone is there on my door. Just give me a minute. Okay. So file, splitter, record reader, mapper, and combiner. Combiner we have added in order to reduce the load of reducer. Then another component that we are going to see practically, that is nothing but partitioner. Okay, so these things are taken care by Hadoop itself, and from developer's perspective you need to bother about mapper reducer, combiner, and partitioner. You need to write down the logic for these particular components, and then you will be able to perform your task. So there are certain, you can say, uh, things that we are going to see practically, and we are going to do the practice onto the Cloudera Quick Start VM itself. And over there we are having Java IDE. Okay, and in that particular ID we are going to, you can say, uh, do the practice. So in next session we will be going to cover those particular components, and we will be going through practically. If you are having any doubt, you can ask. Let me stop recording.